Sure. A very warm welcome to all the participants today for this webinar. I'm Yamini. I lead the hydrogen practice at P Manifold, and I'm glad to welcome you all for today's webinar, where we'll be discussing around hydrogen for road transport, what are the challenges, and what innovations are required for growing this sector. P Manifold is a strategic consulting firm working broadly in the e-mobility, transport, energy, hydrogen, and now even carbon domain. Across our verticals and our services that we provide, we work in policy, strategy, engineering, and trainings. Today with us, we have three eminent speakers from the industry. We have Dr. Ajit Kumar Jindal. He's the head of engineering and R&D at Tata Autocom. With decade of experience in the Indian automotive industry, he has been in the forefront of driving innovation in vehicle systems, especially in emerging technologies like electric mobility. Dr. Jindal brings deep technical and leadership insights into the development and deployment of clean transport solutions in India. Then we have Mr. K. Subramaniam. He's the Senior Vice President at Ashok Leyland, one of India's leading commercial vehicle manufacturers. He leads the strategic initiatives with a strong focus on advanced powertrain solutions, including hydrogen-based mobility. With deep technical and industrial expertise, he plays a pivotal role in shaping Ashok Leyland's transition to sustainable transport. Then we have Mr. Vikrant Vaidya. Vikrant is a partner and lead of EV systems engineering practice at P Manifold. With over 20 years of experience in electric mobility, automotive systems, and vehicle integration, Vikrant drives strategic engagements across e-mobility, hydrogen, and broader transport sectors. I also have Akshay. He's a senior consultant at P Manifold, leading our transport and carbon practice. We'll be sharing some of our analysis from P Manifold. I welcome you all the speakers and guests today, and all the attendees for this webinar. I would like now to hand over to my colleague Shruti. She'll be making a brief context setting webinar so that we are well versed with this heavy duty transportation scenario, and also tell us what we will look forward in this webinar to. Over to you, Shruti.
Yes, thank you, Yamini, for the introduction. So coming to the point, globally, as we know that countries are taking actions to limit the global warming well below 2 degrees. The transport sector is the one which is already contributing to 25% of the overall CO2 emission worldwide. That is the main reason why transport is emerging as a primary focus in majority of the global net zero strategies. Many countries such as Japan, China, Canada, and European Union have already set net zero targets in law. As well, if you can see that Japan has already been very specific towards greenhouse gas emissions to have a transport reduction from its 2013 targets to 46%. Similarly, China is also aiming to have a 40% all new vehicles to be powered by clean energy by 2030. Canada is also having a zero emission vehicles target to because they want to have it 100% zero emission vehicles by 2030 as well. European Union has also set certain emission targets that has to be applied to its member states. As we know, the transport sector is not just about road or rail, but it also contributes shipping, aviation, and pipeline transport. Globally, if we see this particular trend, then road transportation already has a 75 to 90% of overall contribution in the emission. If we see the global trends, then the similar trend has also been adopted in India as well. The transport sector here in India also contributes to 92% of the total transport emission. So road transport is having 92% in India and around 80% globally. So if we see more into this, then the major contribution to the road sector emission is coming from the trucking segment, which is already around 52%. This is more than half of the entire road and transport emission, which is not even contributed by any of the sections as of now. That is the main reason why we have to see major focus on trucks that has to be decarbonized in the coming future. Majority of the application has been seen worldwide to have an alternative fuel for apart from the conventional fuels. As the conventional fuels already having a tailpipe emission, if we see per liter, then kg of CO2 emission is higher in diesel, and then biodiesel, petrol. Also, ethanol is seen as a green gas, but ethanol is still having a tailpipe emission of around 1.5, and similarly LPG and natural gas. But on the other hand, hydrogen as well as lithium-ion batteries, if you see, then they have a zero tailpipe emission. On the other hand, if you see, compared to hydrogen and lithium-ion battery, the energy density of hydrogen is comparatively way higher. This is around 35,000 watt hour per kilos for hydrogen, and which is only 250 watt hour per kilos for lithium ion batteries. If we see the application of hydrogen in the upcoming transport segment, especially in the trucking segment, then there are some green flags as well as red flags. If I see the green flags, then it is having a less charging time, it is having good range extension, it is lighter system for long haul vehicles if I compare this with the battery electric vehicles, because the higher distances brings a heavier batteries and the system weight becomes quite higher on that side for batteries. But on the hydrogen side, it is still on the lighter system weight. But compared to this, the red points here are it is having the lesser efficiency compared to the electric vehicles, and also the less growing infrastructure, that is the slow moving infrastructure for hydrogen. This brings up to some of the challenges that needs to be addressed for the hydrogen adoption in vehicles. Some challenges has to be addressed, such as high cost of vehicles, lack of hydrogen refueling infrastructure, high hydrogen fuel cost that brings into the refueling cost as well as the hydrogen production cost as well. Energy efficiency concerns for hydrogen, as mentioned, it is comparatively very less if the efficiency part is concerned. Policies and incentives has to be addressed accordingly country to country. Safety and regulatory challenges are still there, and limited viability of urban uses. All of these targets, if being achieved, then there has a potential of hydrogen to be seen as the upcoming new vehicle segment fuel for countries across the globe. Thank you, Yamini.
Sure. Thank you, Shruti. I think that was a very brief and quick walkthrough of what we are looking in the transportation sector today, and trucks definitely having a lot of emissions into the broader emission cloud that we see today. But yes, P Manifold has been working, and our team has been working a lot in the ZET segments, evaluating a lot of trucking applications, its impact on emissions. And yeah, I would like to bring my colleague Akshay, who will give us a brief overview of how different trucking applications uh, gets impacted and how its TCO is impacted, to give us a little bit in-depth and technical perspective on road transportation and specifically the trucking segment. Yes, Akshay.
Sure. Thank you, Amini. So, I mean, as Yamini mentioned, we have worked on assessing like what kind of ZDT technologies can, we can see as a potential adoption within the drugs. And for this study, we have looked into 15 different applications and across different vehicle segments in terms of GVWs. And so here we are trying to present some of the the key learnings from this study, where the TCOs are being compared for different powertrains like the diesel, the battery electric trucks, and also for the hydrogen we have conducted the study for H2Is as well as the fuel cell EVs. So here, what we have seen in the parcel load and the steel, for the steel finished products, which have like in the parcel load 40 tonner truck, where for the steel a 55 tonner truck. So these applications seems to have a better parity for the hydrogen trucks, both the H2Is and FCEV, as compared to BET trucks. On for the passenger load, if you see, so currently the diesel, the trucks are having a lower TCO in terms of rupees per ton kilometer. Whereas in the future, the with the hydrogen prices especially be coming down, and also the fuel cell prices coming down, the both the H2Is and FCV TCOs seems to go down. And about it 2028 we see a parity of the hydrogen based trucks with the diesel trucks, which is slightly before than the battery electric trucks itself. So with this I think the hydrogen can play a role in having zero emission trucks, replacing diesel trucks before the battery electric trucks. Similarly, for the steel, also we have seen the hydrogen being a better option uh, 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 in short to medium term, that is like in 2020, 2030 to 2033. I mean, for these two applications, it is majorly because of longer distances in case of parcel load, and the loss of payload, or high batteries size that is required for the steel finished product applications. Similarly, when we have also looked into other application like a market load, which covers a major share in the trucking segment. Here, PETs are more suitable given the range and also the energy consumption. Here, the BETs are already having a parity, and hydrogen trucks are only coming in after 2034 or 37, where the parity is being seen. So I mean, by looking at these different application, for some of the applications, battery electric trucks are very much feasible in terms of having a zero emission trucking. But for some applications like long haul, or having uh, uh, the payload which is higher, so for those applications, hydrogen can be a good option. And so this is a type of adoption that we kind of projected for the ZET technologies. So in 2050, the major share will be BETs with about 40% share. That is this is the annual sales percentage. So here we have seen by in 2050, most of the sales would be electric the battery trucks, and we also see the hydrogen trucks coming in. But the initial years, in between 20 just before 2030, it is more the hydrogen ICE trucks that we'll see coming in, and the FCVs are only expected to come after 2030 or 2032. Uh, so this was a kind of analysis, or the results that are coming from the study that we have done.
Right. Very interesting results, Akshay. I think we will look forward to having comments from our speakers as well on this analysis, especially from Vikrant, Ajit sir, and Subramanian sir. So thank you so much for this background that you have said. Just taking ahead on what you are talking today, my first question is to Ajit sir. So Ajit ji, today hydrogen-powered trucks and buses are at a nascent stage. I mean, people have just launched their products today. So how do you see how OEMs are actually seeing this technology mix that is available today? Like there are BTs, there is H2IS, and there is also hydrogen. So how are OEMs actually looking into hydrogen as a technology for their products?
First of all, thank you very much for giving this opportunity to be present along with you on this webinar on the potentials of hydrogen for heavy duty vehicles. You see, I think the main people are very looking at hydrogen as a technology. From a technology perspective, hydrogen has been there for quite some time, particularly from a fuel cell perspective. There were hydrogen IC engines were thought of long time back, but at some point earlier there were issues related to the NOx emissions, which were a little tricky to handle in hydrogen engines. So that is why for some time this was on the back burner. But now since the emission after treatment technologies have been now developed quite well, and NOx handling, NOx management is not a big deal. So that is why you can see now there are a lot of OEMs are already looking at having the hydrogen IC engines in their portfolio. And as you may be knowing that already many of the OEMs like Tata Motors or Ashok Leyland have already showcased their IC engines, which can be there. But I think so this is one, I think suddenly now with the push on the hydrogen IC engine has come as one of the uh, options for before we go to fuel cell vehicles. Because at one point of time, fuel cell vehicle was considered as the ultimate objective, particularly for long haul trucks, where the battery electric vehicles have got its advantages, but there are some disadvantages in terms of payload reduction and fueling time or the charging time, charging infra. So that is the status as of now, but I think the major issue which currently OEMs are grappling with is the hydrogen infrastructure, availability of hydrogen infrastructure. If we like say if we draw the H2IC engine as a parallel to CNG engines or even for that matter LNG engines, they have been there, they have been introduced in country since many years. As far as I know, right from 1980s, 84, 85, when there was a mandate from Supreme Court to introduce CNG buses or the CNG vehicles within the city of Delhi and maybe other metro cities. The problem is about the infrastructure, availability of infrastructure for fueling. In spite of now maybe almost 40 years, still the IC engines have not been able to capture or substitute the diesel vehicles across the country because no heavy duty vehicle, long haul truck will be uh, feel comfortable or the operators will feel comfortable if there is unless there is a widespread availability of the infrastructure. So till the time there is a good way or good say the clarity about the availability of infrastructure, there will be a big challenge in terms of introducing this. I think the
Right.
second, which as an OEM, what people OEMs look at is, or from the customer perspective, the TCO, the total cost of ownership. I think as far as hydrogen IC engines are concerned, they are little better placed as compared to the fuel cell vehicles, but still they will be expensive. Of course, there will be slight better fuel efficiency as compared to the diesel, which will probably uh, pay off to some extent. But as of now, there is a very big uncertainty about the price of the hydrogen, at what price you will get this. And of course, if we look at the overall, the sustainability aspect, what is the source of hydrogen is also one of the main concern. So I think these are all the many issues which OEMs are grappling. Of course, everybody is working towards mastering the technology, working on technology, and work with the various agencies to see how this whole concept can be made viable. But I think that is where we are at the crossroads, where we have to see that how we go forward in this area.
Right, right. Sure, I think we agree to most of your put up points that I think having a robust refueling infrastructure and supporting infrastructure is very, very important. I want to pose the same question to Dr. Subramanian, and how does he see and how does Ashok Leyland see hydrogen as a technology and its evolution? And like Ashok Leyland is already working with Reliance on H2I. So if you would like to share some bit about this collaboration and any learnings already that we have developed from this product.
Yeah, thank you. I hope you can hear me well.
Yes.
So I think a lot of points covered in the presentation and also by Dr. Ajit. So I will give you a slightly different twist on this. So I think we all agree that in the future, there is a place for battery electric for sure. And I think you quantified it a little bit. And we don't know what else has a place in the future, honestly. We know there will be a mix of other fuels, but we have We can only make some predictions as to what that mix might be. So we are, are not against carbon-based fuels per se, because I think what matters is the net part of net zero. Because if you can use a carbon-based fuel, and I think if you can find a clever way to recycle that carbon back, carbon capture, etc., lots of technologies along those lines, then I think you still have a win, right? So let me kind of tangentially answer your question. Let's take fuel cell vehicles, for instance. So they are the most efficient hydrogen vehicles if the cost of the fuel cell comes down. And of course, if the cost of hydrogen itself and the cost of storage and all that comes down, then fuel cell vehicles have a good chance of taking. So let's take fuel cell. And fuel cells are inherently hybrids because you have a fuel cell that runs on hydrogen and gives you electricity. You also have a battery, which gets charged and also gives charge back to the motor to run the vehicle. So a fuel cell is an electric vehicle that runs both on hydrogen and on batteries. And it's in some sense a true hybrid because you can run the vehicle just from the fuel cell, you can run the vehicle just from the battery. You can run it from both if you want more power. Also, you can charge the battery from the fuel cell. So all of these energy pathways are possible. So I would kind of generalize that definition and say that any combination of a net zero fuel with electric, right, which is a generalized version of the definition of a fuel cell vehicle, where the fuel cell becomes one case in point with hydrogen being a clean fuel, right? So I think any combination, just to repeat, of electric with a fuel that's as close to net zero as possible will be a good bet, in my opinion, right? You can have a hydrogen IC engine with a battery on the vehicle. You can have, I don't know, a bio fuel along with the battery. And I'm just combining the battery part because that's got a few advantages. Of course, you've got to solve all the commercial questions. How do you store the fuel, transport the fuel? How do you make the fuel? All of that is there, right? But I think if you think of it in that perspective, this is kind of my personal thought. While Ashok Leyland is doing a lot of work on hydrogen IC engines, we are also working on fuel cells, but we don't know which will win. Hydrogen IC engines, as far as the company is concerned, will probably a better bet because the initial cost of the vehicle becomes a lot less versus today fuel cell prices. So, but then having set that aside, my personal opinion is this kind of a combination is what might survive in the future. Pure battery electric, as you rightly said in the presentation, is also has issues, right? So that's not the perfect solution. You have a heavy battery, you have likely a big battery, and then you have range anxiety and so on. So a combination may actually be the answer. So I hope I've answered your question at least to some extent.
No, I think this is perfectly fine, sir. I think a very interesting thought that you put up, a net zero fuel with electric batteries is something that would really suffice and be a sustainable solution going forward. And we need to find a balance within the technologies that would come. Talking about technologies, I would like to now come to Vikrant. So Vikrant, as we are already discussing, even in our presentation, we saw that fuel cells typically have a lower efficiency when we say, 25 to 30% compared to batteries, BT trucks, basically, which are 70% more efficient. So how do you see this hydrogen technology with lower efficiency still justifying some use cases in the trucking segment? So what is your take on that?
Sure, thanks. This is a very interesting question, and we do hear a lot of talk also happening around hydrogen as a technology. And we always need to understand the boundaries in which we speak. As you rightly said, I'll just add context to it that the fuel cell has a tank to be is a lower efficiency option as compared to battery electric truck. It is still better than IC engine because the IC engine inherently has a second law of thermodynamics limit. You can't help it, right? So you would have that from time to day. However, the way we are sourcing energy, and I think there have been studies around that, where is it really carbon free? So electricity is being sourced currently largely from the grid. I do not think most of the charger, if not all, today and in near future are going to be powered by the grid. And grid today is 70% or little over 70% coal or other fossil fuels, right? So uh, uh, till that changes, I don't think electric vehicles would be both carbon free as well as efficient. Now, efficiency also then we have to look at in totality, right? The power generation, how it uses the fuel. Look, in case of IC engines, both diesel as well as hydrogen and the fuel cell, you are converting the fuel into energy on board the vehicle, right? And then you are utilizing it for traction purposes. Now, in fuel cell or hybrid electric vehicles, you are converting into electricity because that way you can run the engine or the fuel cell in its most efficient zone, decoupling the transients of the vehicle from the energy source, right? Uh, Something similar you can think of in terms of grid, where the energy production is happening for all multiple purposes, not just for transport sector, and you are taking that. But then from there, you have to transmit it, you have to distribute it, you have to charge the battery. So there are losses there, and quite substantial losses there, right? What is the plant efficiency, one may ask? What is the transmission and distribution loss, and so on? So I think holistically, if we see, we should continue to electrify. That there is no doubt about that, because eventually when we talk about any form of producing the energy, the consumption, now we know that electric is the most efficient way. So we continue doing the electrification, but we also continue looking at what are the requirements from the vehicle. I'll probably elaborate that a little later as well. But looking at the applications, looking at the usage, and what is expected of the vehicle, because finally, particularly in a vehicle which earns livelihood, these are quite low on the priority. What we are discussing today as factors, there it should make business sense. Then everything else, right? So it is important for us to understand how we cater to those requirements with affordable solutions using whatever technology mix. Yeah.
Right. I think affordability aspect is something that you really brought it out, Vikrant, because technology will take its own time to scale with making business sense. When talking about affordability, I think I would like to come to Subramanian sir again. When we talk about the capex of the product, I'm talking about a truck specifically, leaving behind the OpEx part of it, the infrastructure, refueling station. So in the truck, we understand that a fuel cell and a storage system are the key cost drivers there. So do you also see at Ashok Leyland that these are the major cost drivers at a product level, or and what is the potential to actually reduce these costs? Because upfront cost, as we saw even in our analysis, it's been a very important kind of a barrier that is coming up. Of course, I mean, OpEx part will come into play when we talk about lithium, but specifically focusing on the capex of the product, how do you see this cost reductions happening, maybe in terms of some innovations or a scaling up option? So, what is your take on that?
I think you hit the nail on the head. For both fuel cells and for hydrogen IC engine solutions, you still need a tank to store the hydrogen, and often actually multiple tanks. Ultimately, hydrogen is a gas. So you're hit by what they call the volumetric efficiency of a gas, right? So you can only store so much gas in a given space. And you can keep pressurizing it, and there will be safety limits on how much pressure you can go to. As we all know, it is 350 bar today, and hopefully one day in India it will be 700 bar. But then, how much higher can we go, right? And we are also looking, I mean, not we, but the world is looking at cryo storage of hydrogen as a liquid, but looks like that technology is still far out. So we are seeing trends in fuel cell costs going down over time. We don't know how long that trend will continue and what the where it will end up. But I think the common issue, which is tanks and piping, we really need some interesting innovations there. Today, the cost of the tank is as high as it is because it's a Type 4 tank, which is made of carbon fiber composite. And can you make a tank that's much cheaper, right? Doesn't have to be Type 4. I mean, nobody said it has to be Type 4, but Type 4 today gives you the lowest weight. Uh, in my mind, there are multiple options. We are also working on R&D kind of work where we are exploring other options which are non-Type 4 in nature, just so that the costs can come down. Or maybe India will start manufacturing the carbon fiber so that the Type 4 itself can come down in cost. And when Type 4 comes down in cost, there's so many other places on the vehicle that need a cylinder that can actually use those kinds of materials, right? So I think that's the short answer where it really comes down to the tank and the piping. And of course, some of the sensors, valving and the protection systems. And those I'm quite confident with scale, the price could go down, right? But tank, as I said, literally needs some breakthrough innovation.
Got it. Got it. So I think storage tank is something that really accounts a lot of cost today, and we need to work a lot on that and do a lot more innovations in that space to bring down cost. Again, coming back to Ajit sir. So Ajit sir, again, I mean, we spoke about refueling stations that you said, it's important to bring overall ecosystem into place for driving hydrogen. I mean, again, I wanted to understand your perspective on a product level. Do you feel these hydrogen products that are getting launched are mature enough to compete in the market and also do a commercial scale business, or do you think that there is still more space for innovation for us in these vehicles? Of course, storage is something that needs to be looked into from a cost and innovative perspective, but do you have any other challenges that you feel that at a product level we should be ready to mitigate a challenge to grow hydrogen?
Yeah, I think what I believe is that there is a lot of scope for innovation on even on the basic things. Like today, when we talk about hydrogen IC engine is straightforward to my mind uh, as a substitute for the diesel. But when we talk about ultimate goal of fuel cell and hydrogen as a fuel, I think there are potential areas where we do. Today, we have to do, as I already said, that we have to do have tanks which can store more gas, particularly for long haul trucks. You need to carry a large amount of gas on board, and for that you need composite cylinders to keep the weight down, don't lose on the payload. So that is one area where we need to do that. In fact, for quite some time in my previous stint in Tata Motors and even as of late now also, there are potential areas where you can have a probably onboard generation of hydrogen. Maybe there are potential technologies where you can have generate hydrogen on board, thereby eliminating the need for actual storage of the hydrogen, and then use fuel cells which are tolerant to some level of mean they are tolerant to a little bit more impurities in the hydrogen than what you really expect from normal LTPEM fuel cells which we talk about. There you need 99.999 maybe 4 six nines or five nines at least purity. So that is one innovation, and then the fuel from which you generate this hydrogen on board can be maybe ethanol, methanol, or even sometime people are talking about can be generated even from methane or maybe what we call as natural gas. So actually that is a very interesting proposition. The other options are all known already. We talked about, but that this kind of a innovation actually will do a lot of new things. One is, as I said, do away with the storage requirement on the vehicle, and the second thing is you can use, because when we talk of hydrogen, there is always a talk, even in your presentation it was there, what is the source of hydrogen? If we are producing hydrogen from by electrolysis using solar energy, that is the fantastic thing. But if we are generating hydrogen by using carbonaceous fuels or by using other methods, then it is probably only transferring from one place to the other. Then we will lose out on the belt to wheel concept. But yes, if we can generate, we can produce methanol or ethanol from a biomass, which is again a net zero sort of a emission, then there will be CO2 emission, but then that is not really counted as a greenhouse gas. So that is probably one of the potential areas which can be a game changer in times to come for the fuel cell vehicles.
Great, great. I think very interesting and very concepts that you have said, especially the use of ethanol and methanol into the system. I think that's really interesting to know. Coming to that, I think we are talking a lot about H2Is, and I would like to come to Vikrant next on that. Like, how do you see H2Is versus the fuel cell in terms of its technology benefits that we are seeing, and what is your projection in terms of how this trajectory will move? So do you see H2Is just like a transition phase where we want to shift from, conventional to hydrogen, and this H2Is acts like a mediator technology for us to transition? So how do you see? Because I understand H2Is looks like a lot of potential there. So what is your take on that?
Yeah. So what is going for it is it is IC engine, it is comfort zone, and not just for the manufacturers. I would say manufacturers do faster new technologies, but more from the demand side as well, right? The buyers would be more comfortable knowing that there is some kind of engine rather than, I mean, it may not have roots in reality, but it still is reassuring. So, yes, there is some merit in that. Secondly, as both Dr. Jindal said, the purity requirements are significantly lower when we talk about hydrogen ice. Uh, of course, with other kind of penalties in terms of emissions and all. And thirdly, uh, the problem of storage or onboard generation of hydrogen, it is common for both technologies, be it fuel cell or be it hydrogen ice, because you have to either store or make it on board. So I think it may be. I agree with the proposition that it would be a stopgap arrangement till fuel cells become uh, affordable, become reliable, dependable. You see, we talk about life of fuel cell in hours. It's not very confidence inspiring, although the hours are many. But the operations in vehicle terms, you always have to think in terms of kilometers, right? Or maybe years when we talk about warranties and all. So there is still probably a lot of work to do in terms of integrating fuel cell as a technology and a concept into the automotive industry, so to speak, although many fuel cell vehicles have been built. Secondly, I do think from the user perspective, uh, it, it it yeah, as I said, it may provide that comfort, but frankly, they would want to run the vehicle with as much as lower operational cost as possible. So that's where I think fuel cell will become a better choice as the affordability uh, comes to it, because it has better efficiency, fuel conversion efficiency as compared to IC engine. Plus, you have cogeneration and all that possible, because you have that being done already in stationary fuel cells. Yeah. So I think uh, probably till fuel cells become affordable and reliable, we will see hydrogen ICE for those applications. Again, I think many of the applications will be catered to by battery electric trucks with enabled by fast charging. We see a lot of pilots being done even as we speak in two segments, right? 19 or roughly 19 tonner. That is the heaviest truck that you can get with two axles. And then the other end of the spectrum, the heaviest, that is 55 tonner. Ashok Leyland has products there, Zebi products there, Tata Motors has, and even others are looking at those segments. And there, whatever pilots have happened, we have seen they are running. It is feasible to charge even without having super fast charging that takes 1.5 to 2 hours to top up, and still it makes sense to run them. It doesn't give as much disadvantage in terms of the trip duration as well as against the diesel trucks, as we are seeing in the Chennai Bangalore pilot that is happening. It's on. So there are benefits of electrification where you can accelerate, decelerate much faster, and thereby actually recovering some of the time that you would lose in charging. So all of those considered, I think eventually fuel cells is what I see coming up. But as a stopgap arrangement, IC engines, I think would come hydrogen IC engines. But for those specific applications, now we'll have to see if it makes sense for those requirements.
Right, right. I think I agree to that because application level does make a lot of impact on the energy consumption in the vehicle and its performance. So it's better to look into what technologies work for best applications in the trucking segment. So I think this is great to understand all about the technology perspectives and cost. Ajitji, I would like to come back to you because you were talking initially about the refueling infrastructure that came into picture. So we talked about how important it is. So would you like to inform us and tell us about how complex is it to have a hydrogen refueling infrastructure and how basically how difficult or how expensive it is, compared to our, maybe you can compare it with a CNG. What synergies do you see there, having a CNG network versus a hydrogen, and how much we will have to do more to build up this refueling infrastructure? So I just want to gauge the efforts that as a country we need to take to actually rise up the fueling infrastructure there for hydrogen.
Yeah, first of all, just picking forward from what Vikrant was saying, I think in a short term or let's say medium term of let's say 5 to 10 years from now onwards, so probably hydrogen IC engine could be one of the good bets, but provided we solve the infrastructure issues about the availability of hydrogen. This is what I said in the beginning, and probably your question is also that how do we really gear up for first of all the dispensing infra, and then of course about the production of hydrogen. Now where the hydrogen is available, how do we really produce it? These are all the issues. Just to share with you one example, sometime actually there are places where hydrogen is available free as a byproduct. In a lot of chloralkali plants, this is a byproduct and it is available free of cost. It is just being flared. A lot of in refineries also there is a hydrogen production, but sometimes not even captured. So availability of hydrogen, yes, it can be there, but these are all in specific locations. But when you talk about using that, for example, the other way was a lot of work was being done by NTPC and maybe other agencies to have solar farms in Leh and Ladakh and then produce electricity and then convert water to hydrogen and oxygen. Of course, oxygen you can leave in the atmosphere or use it for any other purposes. But hydrogen, capture the hydrogen and then transport it all along length and breadth of the country for distribution, for filling in the vehicle tanks. So that is, I think, one of the biggest challenge in terms of hydrogen. And as I said in my previous say mention, that whether the hydrogen which we are producing is really a green hydrogen, while keeping in view uh, the the overall environment impact, and then transportation, and what is the cost of transportation of the gas from one location to the other. I have seen cases where the hydrogen, the fuel cell trucks, or even the hydrogen IC engine vehicles are already there, but they are limited to the locations where there is a availability of hydrogen, whether it is in some refineries or it is in the some chemical plants where this hydrogen is available as a fuel, as a gas available with maybe very little cost. So that is one very big factor, because we did one study quite some time back for use of hydrogen for in not exactly in the automotive domain, but in the uh, communication towers through fuel cell, having generation was there. But what we found, that though the hydrogen available is free, but transporting, capturing the hydrogen, putting into the cylinders and transporting all the way to different places where these towers are there, that cost was much more than putting other generating systems or the other things. So that is, I think, the major issue. The other part of the, say, the per se the infrastructure, that when you have to fill it in the vehicle, so you have to fill it at maybe today the pressures are 350 bar, but tomorrow when they become 750 bar, so you have to have very high pressure compressors which can compress the hydrogen to that. They are multi-stage compressors, and they are lubrication free, because you can't afford to have any lubrication in the compression system. So they are really expensive compressors. And some time back when I had a check on what could be the price, so each one single charging station which can dispense around 750 kg of gas in a single shift will cost you around 10 to 12 cr, so which is very, very expensive. I don't know the latest prices because I have not checked this, but it is of that order, so that it can fill the vehicle in maybe 10 to 15 minutes as per the normal diesel cost. So, uh, as I said, from a overall infra, one is where do we produce the hydrogen? How do we transport that hydrogen to the dispensing station? And then how do we really compress that for filling into the vehicle tanks? It's a big chain, and a very expensive chain for that matter. I read somewhere that the transportation probably from a long distance where there are already, let's say, infrastructure for natural gas. There, for example, in India, from a Mundra, from this the western side ports, there is already a gas pipeline. So, but if you have a hydrogen available there, maybe hydrogen can be mixed with with the natural gas and transported to wherever it goes, and then you can separate it out. That could be probably do some this, but that is also specific to if you have that infrastructure. If you don't have that infrastructure, then you have to depend upon transporting, or you have to set up a infrastructure for the hydrogen per se, which, as we all know, it has not happened for CNG. So whether it will happen for hydrogen is again a big question mark. So, to my mind, the as Vikrant was saying, the hydrogen, whether it is hydrogen IC engine or the fuel cell vehicles, technologically both things are now already a lot of people have introduced hydrogen IC engines, particularly in the agriculture field. People have already done that. There are proof of concepts. There are a lot of vehicle trials are happening, but till the time we are able to, and hydrogen buses, for example, globally there are a lot of hydrogen buses are already running, and they have proven their reliability. But yes, one point which came out earlier in the discussion, in fuel cell, the life of fuel cell is also one of the issues. Today, the fuel cell stack, 10,000 hours is given, but when you talk about long, having life of 12,000, 15,000, 20,000, in fact, as per my study, our study, you need to have 40,000 hours life for a 10 years period. If you want to run your vehicle for 10 years, you should have a 40,000 hours life, which as of now, no fuel cell stack manufacturer can guarantee you that life, provided you do too much of derating and then use it at a very low level. So that is one big concern. So you will have to have, like batteries, you have to have a midlife change of fuel cell, or at least refurbishing of the fuel cell stack you have to do. It may not cost as a new stack, but at least you will need to refurbish the fuel cell stacks. So which will again be a very major cost as of now. So, in nutshell, I think if we put these things in priority or in terms of criticality, I think having the hydrogen infrastructure and the production of hydrogen, how do we produce that hydrogen so that we are not adding more carbon, adding to the carbon footprint, that will be the most important thing. As far as the technology is concerned, probably that can be, as I said, fuel cell have done reached quite a good, stable, reliable state. They can be improved further, or you can live with that one cell, one life change in a life of the vehicle. But availability of gas at the right price will be the major issue.
Right, right. I think absolutely all points very well taken, Ajit ji, and I think a lot of food for thought also for us on that perspective, like on the supply chain side, where all our focus needs to grow when we want to develop this refueling infrastructure. I think I just want Subramaniam sir to add his perspective also on this point, like how does he see, and I'm sure you agree a lot with what Ajit sir said. And definitely if you want to add more points to that, so I would like you to please do that.
Sure, yeah. Of course, I agree with pretty much all the points that were made. And I agree that the ultimate answer must be fuel cells because they're far more efficient. Question is when, right? I have no idea. It may take 50 years, may take 10 years, I have no idea. And until then, it's for sure hydrogenized. Why am I saying this? Because if you look at it, at how a fuel cell works, if you take a step back, it is taking, I mean, of course, it's reacting hydrogen and oxygen and giving you water or steam, but it's taking the chemical bond energy in the hydrogen and oxygen and converting that to electricity, right? Now, this is a fundamentally more efficient process than burning something. So, as someone mentioned, there's no second law of thermodynamics, or there's much less of it in this process. Um, so, if you look at the human body, right, we take in a carbon-based fuel, which is called food. So it's a hydrocarbon. There's hydrogen, there's carbon, all of that, and we breathe in air, which contains oxygen. So, and we convert that carbon to carbon dioxide, and we convert that hydrogen to water vapor. And when we breathe out, the exhaust, if you will, is carbon dioxide and water vapor, right? So, nature has designed a fundamentally carbon-based fuel system, except that nature has figured out how to reverse it as well. So it also makes plants that take in the carbon dioxide with photosynthesis and makes the carbon again. So So the plant breathes out the oxygen and keeps the carbon to grow itself. Right. So if you look at it in that perspective, and with the additional fact that the exhaust from the human body, what we breathe out, is not a high temperature exhaust. It's a very low temperature exhaust. Right? The temperature increases. So if you blow air from your mouth, you will find that the air is a little warmer than what you took inside. So there is heat coming out, and uh, but there's no NOx and stuff like that. So it's clearly nowhere near that kind of temperature. And which means the human body is inherently working on a fuel cell kind of idea. In fact, it's even better than a fuel cell. A fuel cell only converts the chemical energy directly to electricity. In the human body, it converts to, in fact, direct mechanical motion in some cases. You can move your hands and legs and all that, which is chemical to mechanical, which is in fact what you want in an automobile. You want the energy in the fuel to directly turn the wheels, right? And you also want some electric output, and the human body also needs electrical output. There's a lot of nervous system components that work on electrical signals. Apart from the brain, the heart itself works on electrical stimulus and so on. But that combination of, at a very low temperature, converting chemical bond energy into partly mechanical, partly electrical energy is extremely efficient, right? And that's a fuel cell in some sense. So that is what makes me say that the future has to be ultimately fuel cells. But we don't know how to do that today, right? We only know one version of fuel cells. Even that can't work at such a low temperature that the human body works, right? So just wanted to bring things into that perspective, just so that people kind of get what a fuel cell is versus a combustion kind of process. But until that happens, it's going to be engines, right? And it's not just engines versus fuel cell, but it's also, if it's a fuel cell, you have the rest of the powertrain is electric. So you get the efficiency and the controllability of an electric powertrain as well, right? And that is something that's improving on a day-to-day, year-to-year kind of basis. So that is also something to keep in mind when you look at a hydrogen-based system.
Right, great. I think that's a very interesting perspective that you gave an analogy to a human body and a fuel cell. I think very interesting to hear. Vikrant, your views on this? I mean, how do you see all this, churning into driving a hydrogen economy in the country altogether?
I think the topic is hydrogen. Like the perspective that we have to look at solutions and not one solution that fits all. There, my mind and I think to it that there are applications spaces which need this kind of solution. We should concentrate on those. And, we will get time because BEVs are filling up those applications which are possible by directly using the battery, not losing a lot of payload, which doesn't require a lot of range or can afford to be charging and continue greening our grid, which automatically greens the transport sector. So I think largely, I still feel it is going to be electric, and it's, either IC engine as a stopgap arrangement or fuel cell as a long term, maybe some other technology come up, which is more efficient as said. So it might come up. I think as long as we keep our vehicles largely compatible with the technologies which are there and which may come up or which are on the horizon, and work with the basic fundamental electrification, and then look at these as range extension technologies required for those specific applications. That is what I feel we should take as an approach, because uh, I mean, every single time we have looked for a silver bullet, it was never there. So you have to think of what specific problem we are trying to solve, and how to solve the best possible efficient plan that we can, taking lessons, of course, from the past as well as learning the hydrogen is created, learning from what happens in nature or around us, which has found the most efficient ways of converting energy.
Sure. No, I think that's also an interesting take with Grant. I think that's really great, and I think I have a last question to all the panelists one by one. Again, starting with Ajit ji. So, probably we spoke about the technology, how our OEMs are looking at it, cost, what infrastructure is required, what we need to break these challenges. But at a country level, sir, what are those policy signals that you feel that industry needs today to actually get that support to grow this industry? Be it H2Is or be it, of course, fuel cells, that's the ultimate goal. But what are those policy signals or policy levers that you feel that would definitely help industry to grow? Subsidies, we understand. I mean, that's one area that we really work. But anything apart from subsidy that you feel would really help at a policy level because government is already working on PLI schemes supporting industry to grow. So your views on that?
See, when we means if we are since we are talking about specifically about the hydrogen and then we have discussed all the different options. So the apart from what I mentioned, one another alternate route, not directly, which needs the hydrogen infra, where probably methanol or ethanol or the other fuels, of course, the availability of them, these are also not so easy, but yes, probably they can be made available with more ease as compared to setting up a hydrogen infrastructure. But if we have to go through that uh, well-known route today. This is a new route which is being talked about. But if we have to go through the conventional route of, let's say, hydrogen IC engines or a fuel cell, which is normally called an LTPM fuel cell, the major thrust which probably has to come from the government is in terms of creating the hydrogen infrastructure. Because as I gave in the beginning, the example, leaving that infrastructure for any private entities to do this and set up that infrastructure countrywide is not going to happen. We can have a wishful thinking that some PLI incentive will make people do. You can see that even the CNG infrastructure by the government entities, all these oil companies, they have not been able to do. Whereas a lot of LNG, which is or natural gas, is available at the western coast or even to some extent in the eastern coast, but they have not been able to even work out a way to transport that to inland within the in the heartland of the country. It's not, they have not been able to do, and it can't be left to any private entities to do that. So I think that is the most important and critical inputs which government can do. If they can do this infra, and of course at the same time at what price it can come. Practically, if there are solar farms all over the place, and then you can have uh, hydrogen getting generated through electrolysis, then it can flourish. But without that, I don't think technology is an issue per se. It can be made to work. It will take some time to stabilize and all that. That is fine. But making the fuel available, this is my experience of so many years that when we talk about CNG, when we talk about LNG, when we talked about even fuel cell, the first question in the mind of customer is, if I buy today a hydrogen truck or a hydrogen IC engine truck, can I buy it in Pune and then go into Assam and sell it there? Or I can run this there. So till the time somebody is able to give him that assurance, we may master the technology, but he is not going to buy this. That's very clear. So from a government perspective, I think if government, I think same is true for even battery electric vehicle also. If the infra for charging is not there, we know that the way we anticipated that battery electric vehicles will grow, It is not growing. It is come to a stage, but then beyond that, it is just stagnating. It's not only India phenomena; it's global phenomena. Similarly, even hydrogen. I know I have seen hydrogen stations 40 years back, but yes, you can have one or two, but unless you have got every 5 kilometers or every at least 100 kilometers hydrogen stations, it's not going to work. We can always think, but it will never happen. So, according to me, if the government single thing which maybe has to be done is set up that infrastructure. If we and of course availability of hydrogen and infrastructure. If these
Right.
are done, everybody will be happy to buy, as we have discussed from an efficiency perspective. And I have done some calculations. Yes, if the hydrogen is at the right price, it will be the most efficient solution and most environment friendly solution.
Right, right. Absolutely. I think that ripple effect of the cost will definitely see a lot of effect on the adoption of the technology. So I think you have rightly summarized that. Subramanian sir, what is your whole and soul ask from the government for this?
Ask from the government and from all of you as well is I think to truly enable hydrogen to take off, I think we all need to work together. That collaboration is important because there are fundamental problems, like the tank is one of them, but there are other problems as well that need to be solved in order for us to collectively take hydrogen forward. So it's government plus people who work on policy, plus people who work on technology, which includes academia and industry, and plus the people who work on product, which is people like us, right? So that to me is the order of the day. There are still unsolved fundamental problems, both in the generation of hydrogen and the transport and storage of hydrogen. In the combustion of hydrogen, also, I would kind of add because there are studies that show that, even products today that show that if you do direct injection engines, the DI engines, you can actually get efficiencies which start to approach fuel cells in hydrogen engines. So I'm not saying they would be better than fuel cells, but you can get close. So there are fundamental issues like that, right? So we need to get together. Even people who compete need to get together. Second one, in a lighter vein, I would say something that Dr. Ajit mentioned a few minutes ago is what if you have a fuel cell that can run both directions, right? Can you, in one traditional way, you give hydrogen, it makes electricity. That's what it does today. What if I can come home, I can auto my depot, and I can plug in fuel cell, perhaps pour some water, and I can make the fuel cell generate and store hydrogen if it runs in reverse, right? So it takes the water, uses the electricity, and splits the water into hydrogen. It is in theory possible, right? So something, it's like a battery which both charges and discharges. So the chemical reaction works both ways. So that to me would be the real holy grail, because that type of charging, if you will, would be even better than storing the energy in a battery. Because again, like you showed in the slides, the hydrogen stores a lot more energy per kilogram, right? So in a lighter vein, I'm sure I've seen a couple of papers around the world, people working on something like this. But if something like that becomes a reality, then you have a vehicle where you can literally charge or recharge the hydrogen.
I think this is again a very interesting perspective that you brought into, so we need to do on the technology front as well, and it has to be a very collaborative effort that we need to make things work. Vikrant, your final take on this altogether, I think very interesting discussion on this fuel cell that can work both ways. I think that's
Right.
a very on the technology front to make
Yeah.
things happen. But yes, apart from technology also, policy level as well, we need a lot of things to do. So yes, would like to hear from you.
Right, right. So I think policy usually supplements and supports uh, not directly but indirectly those technologies which make sense. Not just they do, but should do as well. Say, I think looking at the problem that we are trying to solve, looking at it whether it really exists. So if there are technologies where you don't have to actually carry the hydrogen, particularly pressurized and or cooled to that extent, then we actually circumnavigate that problem with a reduced. So both Ajitji, we talked about alternate fuels, having the reformer on board. In fact, solid oxide fuel cells work with hydrogen, just like PEM fuel cells that we talk about in automotive, but solid oxide fuel cells were even hotter, much hotter, like IC engines, in fact. But they have built-in reformers, so they have that fuel flexibility. They run on biodiesel and all, right? So uh, uh, that is one, and then you could basically have something like, I do not know, direct methanol fuel cells have also been tried, not recently, since many years, if not decades. So there you have possibility of flexibility in fuel. I'm not saying direct methanol fuel cell will work, uh, definitely work in a truck or something, but what in my past studies I've seen their power output and all is much lower. But you could stack them up, they are essentially cells. So I do not know how that could be scaled, but that could be a potential thing, working with flexible fuel. The other part is, as said, that we at it in terms of charging, discharging kind of. I would extend a little bit to it. Look at and the policies should look at how we make, how we reduce this transport and all of energy, right? So we talk about charging stations being powered by solar, right? Why not integrate hydrogen there? The main problem we have with solar is that we can only generate 8 hours a day, whereas the demand would be many more hours. And there you could actually be flexible in terms of generating more electricity through solar, using the excess, either storing it in the battery or actually making hydrogen, and that they could then dispense both electricity as well as hydrogen to whatever fuels are coming, right? Whatever vehicles are coming. And we always again talk about hard to reach places where we may not be able to put up chargers, may not, the grid may not reach in that shape and form as required for high power charging and all that. I mean, same would be true for hydrogen, I would say. If you are thinking of transporting hydrogen to somewhere like Manali, and yeah, it's going to be the same problem. It's actually going to be even bigger problem to transport hydrogen there. So I would say look at also government should look at also policies which encourage self-sustained units of energy. Now forms could be converted whichever way maximizes the efficiency, but look at solutions which can be self-sufficient, and it is then easier to make them green quickly, as against greening the grid is again 20-25 years plan, right? And until then, I mean, whether it's grid or whether it's hydrogen, unless you have green hydrogen or a green grid, you are not really solving climate problem per se.
Right. I think green, the definition of green needs to be really true to what we want to do in terms of renewable addition and, taking measures that eventually reduce your emissions through different self-sustained technologies, which are actually green. So yes, I think we need to have a very holistic approach to look at how we do decarbonization of our transport sector, especially road and in that the trucks and the buses segment. I think very interesting insights that came from all our speakers. So thank you a lot. If anybody has some questions, please do share.
Some of the questions were answered,
Okay.
right, of the answers. Yeah.
So anybody from the team would have some questions? Okay, I think we don't have any questions at the moment, and I think we are within our time frame also. Subramaniam sir had a hard stop uh, to this engagement. But I think very interesting from all of you. Very good insights that we have got, and I hope our attendees also found it very insightful, the kind of perspective that came in. And I would like to thank all of you once again for joining. We look forward to doing more webinars each month. So please join us on these knowledge sessions that we are looking to impart every month under our hydrogen practice. Thank you a lot, and we'll see you again.
Yeah. Thank you very much. Thank you. Thank you, Yamini.
Thank you.
Thank you, Vikrant.
Thank you, Subramaniam sir. Thank you, Vikrant.
Thank you, Mr. Subramaniam. I think he's left. Okay.